Welcome to this explainer. Okay, today we're cracking open an astrophysical cold case. It's one that's honestly had astronomers scratching their heads for decades. We're looking at Caldwell 25, also known as the Intergalactic Wanderer. It's a seemingly quiet cluster of stars that is actually hiding a massive cosmic secret. If you've ever wondered what happens when galaxies literally collide, or how we can use light to do forensic science across the universe, well, you are in the exact right place. Let's jump right into the staggering number. 300,000. That is the distance, in late years, to this object located way out in the Lynx constellation. Just to put that into perspective for a second, our entire Milky Way galaxy is only about 100,000 light-years across. So Caldwell 25 is sitting way, way out in the remote outer halo, far beyond the bustling spiral arms where we live. And honestly, this extreme isolation is our very first clue at the crime scene. It immediately begs the question, how did a massive, densely packed cluster of stars end up so incredibly far away? Standard globular clusters usually swarm much closer to the galactic center, so sitting out here in the sparse outer halo, yeah, that makes it a highly suspicious wanderer right from the get-go. Now, we aren't the first to realize that something is completely off about this object. Astronomers have known it was weird for over a century. I absolutely love this quote from 1922 because it beautifully captures that early intuition. The legendary astronomer Harlow Shapley just called it a globular cluster of uncommon interest. Even with early 20th century telescopes, Shapley hit the nail on the head. This was no ordinary collection of stars. A color magnitude diagram plots the color of the stars against their brightness, essentially showing us exactly what Shapley and later astronomers were looking at. You can clearly see a distinct layout here. There's an extended tail of hot blue stars, and then a defined cluster of aging red giants. At first glance, sure, it looks like a standard star cluster, but hitting deep within this data is a major anomaly. Which brings us to Section 1, a bizarre chemical inventory. Let's look at the suspects. So looking past just the brightness and digging directly into the cluster's internal chemistry reveals our first massive piece of evidence. And this is where the plot really thickens, because we actually have two prime suspects living together in this single cluster. On one hand, population 1 looks like your normal, everyday halo stars, expected levels of nitrogen, helium, and magnesium. But population 2? Completely bizarre. It's highly enriched in nitrogen and helium, and strangely depleted in magnesium. But what's truly wild is the ratio between these two groups. They're split almost perfectly down the middle, 55% population 1 and 45% population 2. This is highly abnormal. For a simple, standard globular cluster, you'd expect all the stars to be born from the exact same cloud of gas at the exact same time, sharing a single uniform chemical fingerprint. Finding a near 50-50 split of two totally different chemical profiles, that is a massive red flag. Now, actually spotting the difference between these two populations from 300,000 light-years away is incredibly tricky. Model spectra of the red giant stars map the chemical differences across different wavelengths of light. You can really see the distinct blue and red lines. But to actually detect this from Earth, scientists had to get pretty creative. They turned to the Hubble Space Telescope, specifically utilizing the F343N and F336W filters. By isolating very specific ultraviolet wavelengths, right near 3,400 angstroms, these filters act literally like forensic blacklights at a crime scene. They isolate the specific light absorbed by nitrogen-hydrogen and oxygen-hydrogen molecules, beautifully exposing the heavily nitrogen-rich nature of that mysterious population 2, which exposes a massive contradiction. If Caldwell 25 is just a standard star cluster, how on Earth could it forge two completely different chemical signatures? Normal globular clusters simply don't have the gravitational weight required to hold on to the fast-moving gas and enriched elements cast off by early supernovas. They shouldn't be able to form multiple, distinct, chemically enriched populations like this. It just doesn't add up. Moving on to Section 2, the dynamics of isolation. Preserving the crime scene. Because the chemistry clearly tells us this object shouldn't exist as a normal cluster, we've got to look at its structural physics to find our next clue. Caldwell 25 has some extreme anomalies. We're talking a very extended physical size and a staggering weight of nearly 1 million solar masses. But the real smoking gun? It has an unprecedented half-mass relaxation time of 55 billion years. In astrophysics, the relaxation time is essentially how long it takes for the stars in a cluster to gravitationally interact and mix up their orbits. Just think about that for a second with a true sense of awe.
The universe itself is only about 13.8 billion years old. So a 55 billion-year relaxation time means the cluster structure hasn't fundamentally changed since the very moment it was formed. Actually, scratch that. It hasn't changed at all. Whatever extreme, chaotic environment birthed Caldwell 25 and its two distinct populations of stars, the evidence hasn't been erased. It's still perfectly preserved today, totally unmixed by the cosmos. It's basically a perfect, untouched fossil.
So where did it come from? That's Section 3, Tracking the Polar Orbit. Let's open the detective's toolkit. To figure out where this impossibly heavy, chemically bizarre, perfectly preserved fossil originated, astronomers had to map its exact 3D orbit, and they used a pretty powerful toolkit to do it. They created a step-by-step roadmap. First, gather deep optical imagery using Hubble. Second, combine that with ultra-precise proper motion data from the European Space Agency's Gaia satellite. And third, they needed a fixed point to anchor these minute movements against. To get that anchor, Hubble captured images of a faint, distant background galaxy located way, way behind Caldwell 25. Because this galaxy is so incredibly far away, it appears completely static in our sky. By measuring the movement of Caldwell 25 stars relative to this unmoving background galaxy, scientists were able to calculate the cluster's absolute trajectory with amazing pinpoint accuracy.
And the resulting math? Totally eye-opening. Caldwell 25 wasn't orbiting the Milky Way in a normal circular path along the galactic disk, not at all. Instead, it's on a highly elongated, nearly polar orbit. It plunges in toward the Milky Way to a close approach, or pericenter, of about 53 kiloparsecs, and then slingshots way out to a distant apocenter of around 98 kiloparsecs. That's a massive looping trajectory.
Which leads us to Section 4, a stolen galactic core. Time to unmask the culprit. This bizarre, plunging movement is the final puzzle piece we need. When mapping the sky trajectory and radial velocity, that looping path perfectly matches another object. Seeing the orbit maps side by side reveals something incredible. Caldwell 25 shares the exact same polar trajectory and the exact same sense of rotation around the Milky Way as the Sagittarius dwarf spherical galaxy. Boom, the mystery is definitively solved. Caldwell 25 is not a standard Milky Way globular cluster at all. It is highly, highly likely a fragment that was violently torn away from the Sagittarius dwarf galaxy. The extreme distance, the immense mass, that totally bizarre split chemistry, all of it exists because this object was actually formed inside the heavy gravitational well of an entirely different galaxy. What we're actually looking at here is a stolen galactic core. Over millions of years, our own Milky Way basically acted like a cosmic thief, mercilessly ripping the smaller Sagittarius dwarf galaxy apart. And in the process, the Milky Way stole its most massive, dense star clusters. While the rest of the dwarf galaxy was shredded into faint streams of gas and stars, Caldwell 25 was dense enough to survive, left wandering all alone in our outer halo as a relic of this cosmic collision. Which leaves us with a pretty thrilling final thought. If Caldwell 25 is just one stolen jewel from a destroyed neighboring galaxy, what other stolen galactic cores might be quietly wandering the dark edges of our Milky Way's halo, just waiting to be unmasked by the next generation of telescopes? The cosmos is a messy, deeply dynamic place, and our galaxy is clearly full of these hidden fossils. Thank you so much for joining me on this explainer. I really hope this sparked your curiosity, and I'll catch you next time.